Hey guys, what's up? Welcome back to the class. It's Mr. Low. Okay, and today we're gonna discuss about inequalities. Okay, I understand that some of you find this particular section very confusing. Okay, so here I am trying to record a detailed video trying to explain this whole part. Okay, so without further ado, let's get right into it. Okay, so we have the four inequality signs that we are familiar with. Okay, we are familiar with how it is used in numbers, right? So for instance, 7 is greater than 4. This is, of course, we can also write 7 greater or equals to 4 because, well, it is greater than 4. So it is greater or equals to 4. No problem about it, okay? But usually people just write greater than 4, okay? So here we have this particular table here, okay, whereby we discuss about what happens to the inequality sign when we plus, minus, times, or divide by positive or negative numbers. Okay, so the summary is given on the right hand side of the notes. Okay, please take a look. All right, so I'm gonna go into detail for this part. Okay, if you're already familiar or if you already understood this part, just go ahead and skip to the next section. All right, so for those who are still not very clear about what this whole part is trying to say, okay, let's go into detail first. Okay, so we're going to discuss what happens if we add or subtract. Okay, well, if we add or subtract positive or negative numbers. Okay, what happens when we add or subtract positive or negative numbers in an inequality? Okay, so here we have an example. For instance, we know that 5 is smaller than 6. Okay, so let's try to add positive numbers to both sides. Okay, of course, when we want to add numbers to an equation or an inequality, we have to do it to both sides. Okay, as usual. Okay, so let's try adding a positive number. Let's say that's plus 10. Let's add 10. Okay, so what happens? On the left hand side, we have 15. Right hand side, we have 16. Well, 15 is still smaller than 16. So you realize that, okay, the sign remains the same. All right, let's go ahead and add a negative number instead. All right, so we have 5 smaller than 6. Okay, so what happens if I add a negative number? Let's say I add negative 4, which is the same as minus 4. Okay, adding a negative number is the same as subtracting that number. So let's say I add negative 4 to both sides. What will happen to the left hand side? Well, 5 minus 4 is 1. 6 minus 2 is 6 minus 4 is 2. You realize that the inequality doesn't change. So if somehow I need to add or subtract numbers, okay, to both sides of the inequality, the sign will not change, whether is it positive or negative numbers. Let's look at case number 2. What if I multiply, so this is case 2. Okay, what if I multiply both sides by positive or negative numbers? Okay, so we're going to use back the same example. 5 smaller than 6. Okay, let's multiply both sides by a positive number. Let's say I multiply by 3, for example, right? 5 times 3 is 15. 6 times 3, 18. Okay, and you realize that the inequality sign, no change. Okay, there's no change. Now here's interesting. What happens if we multiply by a negative number? Let's multiply by negative 3. Okay. All right. So what happens here? On the left hand side, you have negative 15. On the right hand side, you have negative 18. Now, if you're familiar with your negative numbers, you would know that, in fact, negative 15 is greater than negative 18. Okay, so you realize here there is a problem. The inequality sign has changed. All right, so this is what happens if we multiply both sides of an inequality by a negative number. Okay, the sign would change immediately. Okay, so let's look at case number 3. We divide both sides by a positive or negative number. Okay, as you can probably guess, something would also happen when you divide by a negative number. So let's take an example. Let's say 15 is smaller than 20. Okay, I'm gonna find a number that is divisible. Okay, so let's say we try to divide by 5, a common factor. All right, so what do we have here? On the left hand side we have 3, on the right hand side we have 4. Well, 3 is still smaller than 4, so you realize that just like when you multiply by a positive number, there is no change in the inequality sign. But what if we divide by a negative number? 15 less than 20. Okay, I'm gonna go ahead and divide by negative 5 on both sides. What will happen? Okay, on the left hand side you have negative 3. Okay, on the right hand side you have negative 4. So you see the same problem, not the same problem, the same phenomena appears. Okay, negative 3 is bigger than negative 4. So you see there is a change in inequality sign. Okay, so we look at all these 6 cases. Okay, we plus and we add and we subtract numbers. We multiply by positive and negative numbers. You divide by positive and negative numbers. What do you realize? There are only 2 cases whereby the inequality sign would change, which is this is case number 1, case number 2. Okay, so this is when you multiply or divide by negative numbers, you need to flip the inequality sign. The inequality sign will flip. So this is the part that I'm trying to say. Right, this is the only case. Okay, so here we deal with inequality sign involving numbers. But in the next section, we are dealing with algebra. Okay, inequality sign involving algebra. Okay, so what does it mean? What does inequality sign involving algebra means? Let's say I have x smaller than 5. Okay, now x is a number. Okay, and we say that this unknown number x is smaller than 5. So my question is, what value can x take? Usually when we deal with equations, we have something like x equals to 5. Okay, so when we have x equals to 5, in this case, it's very clear. When we draw the number line, okay, 0, 1, 2, 3, pardon me, let me erase the arrowhead, okay, 3, 4, 5. Okay, so this is negative 1. Okay, when we have x equals to 5, let me use green color to box it up. Okay, we know that very clearly this is the value of x. Okay, there's only one possible number for x when we say x equals to 5. That is the number 5. But if we say x is smaller than 5, okay, then we have something interesting. That means any number that is smaller than 5 can be a possible value of x. For instance, well, x equals to 4.99 is okay, is possible value for this. Okay, let me divide this part. Okay, x is 4.99 is possible. What else? X is negative 100, 1000 is also possible because why? It is smaller than 5. Okay, but any number that is equal or bigger to 5 cannot. So for instance, x equals to 5 itself cannot, right? Because it is not smaller than 5. X equals to 5.01 cannot, because it is not smaller than 5. All right, so when we have an inequality involving an algebra, all right, an unknown, that unknown can take multiple values. Okay, now, so let's move on to equations. I should say inequalities, and how do we solve them? All right, so let's look at example number 1 here. Okay, a very simple example. 2x is smaller than 12. Let me write by the side. Okay, so we have example 1 here. X 2x is smaller than 12. Okay, now in order to understand or to help you to see how to deal with inequality easily, okay, let's see how we usually deal with equations. So usually we have this, right? The only difference is instead of equal sign, we change it to inequality sign. So how do we deal with this over here? How do we deal with this? Well, we are all very familiar with it. We divide both sides by 2 so that I can cancel, and we are left with x equals to 6. All right. So as you can see here, when we have x equals to 6, we have a fixed value, or I should say we have only one value for x that satisfies this equation. What do I mean by satisfy this equation? Let's come back to the original equation here, 2x equals to 12. If I substitute x equals to 6 into it, what do I get? On the left hand side, I have 2 times 6, which is actually 12. So this value here, x equals to 6, we say it satisfies the original equation because your left hand side here equals to the right hand side. Okay, after you put in that number. Now, what happens now when we have inequality? Well, we kind of deal with it the same way. Okay, we divide both sides by 2, then we go ahead and cancel. Okay, now in this case, you might be asking, do I need to flip the inequality sign? The answer is no, because we are dividing both sides by positive number, which is 2 in this case. Let's go back to the previous example. Okay, over here, you see that we are dividing both sides by a positive number, positive 5. Nothing happens to the inequality sign. All right, so here we are dividing both sides by 2, so there's nothing to be done to the inequality sign. So we have x lesser than 6, and we're done. Okay, now recall, what does it mean by x smaller or equals to 6? That means any number that is smaller than 6 would satisfy this equation. For instance, let me choose x equals to 1. Just an example. Okay, example. X equals to 1 is indeed smaller than 6. Let's see how it satisfies the inequality here. Okay, so let me put in x equals to 1. Let me write it down first. 2x is smaller than 12. Okay, now if I substitute x equals to 1 into the equation, into the inequality, I have 2 times 1. All right, 2 times 1 on the left hand side is equals to 2. Now, is 2 smaller than 12? Yes, answer is yes. So this is true. That means x equals to 1, right, will satisfy the inequality above, no problem. Okay, but what if I put in a number, instead I choose a number that is greater than 6? What will happen? Let's see. If I choose x equals to 7, for example, okay, example, if I choose x equals 7, then I substitute back into the inequality, 2x is smaller than 12. Let's see what happens. 2 times 7, all right, that is equals to 14. Is it smaller than 12? No, answer is no. Okay, it does not, is not smaller than 12. Therefore, this number here, x equals to 7, does not satisfy. Does not satisfy inequality. All right, so this is what we mean. Okay. So let me sum up this part here first. When we deal with the usual equation, like this part on the left hand side, okay, we have one particular answer, one particular value for x when we solve the equation. But for inequality, we get instead a range of values for x. Some is a range of value of x such that x can take possibly many numbers so long as it is in line with the inequality that we solve at the end of the day. So for instance here, any number for x that's smaller than 6 would be okay, but anything that's bigger than 6 is not okay. Alright, so here we are dealing with an example whereby we are dividing both sides by a positive number. Nothing happens to the inequality. Now let's check what happens if we divide both sides by a negative number. This is where example B comes in. Alright, so let me work out example B in detail so that you can see how it's done. Right. So let me work below. Okay, the question says negative y negative y plus 4 is smaller or equals to 5. Okay, so here, how do we usually deal with this? Like when we deal with an equation. If we have negative y plus 4, for instance, negative y plus 4 equals to 5. This is what we usually do, right? How do we do this? Well, we simply move the 4 over to the other side. So what happens? Plus 4 becomes minus 4. Negative y equals to 5 minus 4. We have negative y equals to 1. And then we want to isolate the y. So we divide both sides by negative 1. So that I can cancel the negative sign with the negative 1. And what do I get in the end? I have y equals to negative 1. Just one particular value, negative 1, nothing else. Alright, so this is when we deal with equations. Now, when we have inequalities, again, the similar way that we deal with it. Okay, I see that I have a plus 4 here. I shift over. Okay, also becomes minus 4. So I have negative y smaller or equals to 5 minus 4. Okay, now many of you will be tempted to do this. Many of you will be tempted to write negative y equals smaller or equals to 5 minus 4 equals to 1. This presentation is absolutely wrong. Please do not do this. Don't be tempted to write equal sign over here because we are dealing with inequality. Please do not write equal sign. Otherwise, you may end up becoming an equation, not an inequality. Please take note. Okay, so what can we do instead? How do we present? Instead, we just continue writing negative y smaller or equals to 1. All right. Now we see that next step is also very similar. Okay, we divide both sides by negative 1 because I want to isolate my y. Okay, so instead here, what I'm going to do here, I'm going to write divide by negative 1, divide by negative 1. Okay, so this is the difference here. Okay, now what happens here? Well, remember that when we divide by negative number, first we need to change the inequality sign. We need to flip it around. Okay, now so negative y over negative 1 greater or equals to 1 over negative 1. So the difference between an equation, which is the right hand side, and here is that we have to take care of the inequality sign when we deal with dividing or multiplying by numbers, especially negative numbers. So here I can carry on doing the usual cancel. Alright, I'm left with y greater or equals to negative 1. And we're done. Again, this means that any number that is greater or equals to negative 1 for y will be okay, would satisfy the inequality right at the start. This inequality, it will satisfy. So for instance, um, y equals to 1, for instance, is greater than -1, you can try, it will still satisfy the inequality. You can substitute in any numbers that is greater than -1 or -1 itself into this equation. You see that it's okay, it will satisfy the inequality. Alright, so for this next few parts, the idea is the same. You treat this inequality like how we usually deal with equations, but you must be careful that we are dealing with inequalities. We must change the sign. We might have to change the sign as and when. Alright, so look through these few questions and see if you understood what I said just now. Alright, thank you for watching.